Deep. Beneath the Pacific Ocean, an Oregon seafloor volcano is awakening, and scientists are panicking because what is happening right now should not be possible for another year. Axial Seamount, a volcanic monster the size of Mount Rainier, sits in complete darkness beneath 1 mile of crushing ocean water. For decades, it followed a predictable pattern: inflate slowly, erupt, reset. The cycle took 13 to 15 years like clockwork. But that clock just shattered. Pressure inside Axial Seamount has spiked to 95% inflation, the exact same level that triggered its last massive eruption. Except this time, it is happening 10 months early. The magma is not just building, it is surging. And the scientists who successfully predicted Axial's last eruption are now admitting they do not understand what is driving this terrifying acceleration. But here is what has the entire Pacific Northwest bracing for catastrophe. Axial Seamount does not erupt alone. It is connected to the same underground network that feeds every major volcano in the Cascade Range: Mount Rainier, Mount Hood, Mount Shasta. When Axial finally breaks, the energy release could trigger a chain reaction through a 600-mile fault line capable of unleashing a magnitude 9 megaquake. 3 massive earthquakes from across the Pacific have already hammered this volcano in the past 6 months. Each one accelerated the timeline. Each one pushed Axial closer to its breaking point. So what happens when the most monitored underwater volcano in history erupts months ahead of schedule? And if the Pacific Northwest's geological foundation is more connected than anyone realized, what else could this single underwater explosion set in motion? December 20th, 2025. Sensors buried beneath 1 mile of Pacific Ocean water transmit readings that send shockwaves through the scientific community. Axial Seamount's inflation has reached 95%. The same deadly threshold that preceded its massive 2015 eruption. But the timeline is catastrophically wrong. Chadwick, an Oregon State University geologist who has studied Axial for over 3 decades, stares at data that defies everything his research predicted. The volcano was supposed to reach this point in late 2026. Instead, it has arrived 10 months early. The margin of error in his models cannot account for this acceleration. Something fundamental has changed beneath the seafloor. Chadwick's team built their reputation on understanding Axial's predictable behavior. The volcano inflates gradually as magma accumulates in its chamber. Pressure builds over years. When inflation reaches approximately 95% of the previous eruption threshold, the system ruptures. Lava pours across the seafloor. The cycle resets. This pattern held for decades. The 1998 eruption followed it. The 2011 eruption confirmed it. In 2015, Chadwick's team used this consistency to issue a public forecast that Axial would erupt before year's end. The volcano obliged within days. That predictability made Axial the most reliably forecast volcano on Earth. Now that reliability has evaporated completely. Current pressure readings show magma accumulating at 4 times the normal rate. Seafloor sensors detect continuous micro-earthquakes rippling through the volcanic edifice. The inflation curve that should climb gradually over years is spiking nearly vertical on monitoring graphs. Every instrument on the seamount confirms the same alarming trend. Chadwick's colleagues at monitoring stations across the Pacific Northwest review the incoming data with growing unease. The models they trusted no longer apply. The timeline they calculated has collapsed. The volcano they thought they understood is behaving in ways that challenge fundamental assumptions about how submarine volcanic systems operate. The magma is not just building anymore. It is surging toward the surface with unprecedented speed. And the scientists who mastered Axial's patterns are now admitting a terrifying truth. They do not know what happens next. 300 miles off Oregon's coast, lies a volcanic mountain that most Americans have never heard of. Yet Axial Seamount ranks among the most active and dangerous volcanoes in North America. The reason for its obscurity is simple. It exists in complete darkness beneath nearly a mile of crushing Pacific water. Out of sight, out of mind, but never out of danger. The numbers reveal a geological titan. Axial rises 3,600 feet from the ocean floor. Its volcanic edifice spans an area comparable to Mount Rainier. The summit caldera stretches nearly 2 miles across. Lava flows from previous eruptions blanket the surrounding seafloor for dozens of miles in every direction. This is not just another underwater hill. It is a monster hiding in the abyss. What makes Axial particularly dangerous is its location. The volcano sits directly atop the Juan de Fuca Ridge, a tectonic spreading center where new oceanic crust continuously forms. Here, the Earth's mantle pushes molten rock upward through cracks in the seafloor. Magma does not arrive in occasional surges. It wells up constantly, feeding a volcanic system that never truly sleeps. Unlike the explosive stratovolcanoes that dominate the Cascade Range on land, Axial operates differently. The seamount inflates and deflates like a colossal subterranean lung, breathing molten rock in cycles that scientists tracked for decades. Pressure builds as magma fills the chamber below. The seafloor swells measurably. Then, eruption releases the accumulated energy. Lava floods across the ocean bottom. The volcano exhales. The cycle begins again. This rhythmic behavior made Axial the most predictable volcano on Earth. Scientists installed extensive monitoring equipment across its summit. Pressure sensors, seismographs, GPS instruments measuring seafloor deformation down to centimeters, and underwater cameras capturing hydrothermal vents in real time. No volcano in history has been more thoroughly wired for observation. That monitoring network was supposed to provide years of warning before the next eruption. Instead, it is now recording an acceleration that defies every model scientists built. The invisible giant is stirring faster than anyone believed possible. July 29, 2025. A massive 8.8 magnitude earthquake strikes off Russia's Kamchatka Peninsula with devastating force. The rupture unleashes seismic waves that race across the Pacific Basin at the speed of a jet airliner. 4,000 miles away, those waves converge on Axial Seamount. Pressure sensors on the seafloor go haywire. The instruments detect the disturbance even through 1 mile of ocean water. Within hours, earthquakes begin rippling through the volcano's magma chamber. Monitoring stations record inflation rates doubling, then tripling. Scientists watch their data streams with growing alarm. Something has changed deep beneath the seamount. The first blow lands hard, but it is only the beginning. November 2025. A second seismic hammer strikes from 2,400 miles to the south. A 7.9 magnitude earthquake ruptures the Tonga Trench, generating a tsunami that sweeps across the South Pacific. The seismic waves travel through the ocean crust and arrive at Axial with punishing force. The volcano shudders in response. Fresh lava erupts onto the seafloor within days. Underwater cameras capture glowing streams of molten rock spilling from vents that had remained dormant for years. But scientists recognize this activity as merely a prelude. The real danger is building below. By month's end, Axial's inflation rate has quadrupled. Processes that should unfold over years are compressing into weeks. December 8th, 2025. The final trigger strikes closest to home. A swarm of earthquakes rattles the Blanco fracture zone, a fault system slashing across the Juan de Fuca Ridge just 60 miles from Axial's summit. Seismographs record over 2,000 individual quakes within 24 hours. A dozen exceed magnitude 4.0. The geological assault continues for days. It is the equivalent of a slow-motion hammer blow delivered directly to Axial's foundations. The pattern shatters completely. By December 20th, 2025, inflation tops 95%, the same threshold that triggered the massive 2015 eruption. 3 seismic events from across the Pacific, 6 months of relentless geological assault, and a timeline that has collapsed from years into mere months. May 1933. A United States Navy subchaser patrolling off Oregon's coast records something extraordinary in the ship's log. The entry reads simply, "Awakened by a light at 0500, picked up several pieces of volcanic rock floating in the water with gaseous bubbles coming from them." That log entry, lost for decades in naval archives, represents the first known record of an eruption at Axial Seamount. Scientists now believe the 1933 event produced a submarine lava flow that built an underwater plateau larger than San Francisco. The true power of Axial's eruptive cycle remained hidden until modern technology arrived. July 1998. Seafloor seismometers record a massive seismic swarm beneath the seamount. Over 8,000 earthquakes rattle the volcano in just 11 days. Some tremors resonate through the Earth's crust powerfully enough to reach monitoring stations in Idaho. When a remotely operated vehicle visits the site months later, cameras reveal 10-meter-long lava flows blanketing the sea floor. Axial had unleashed a major eruption in complete darkness. The pattern repeated in April 2011. After 13 years of steady inflation, the volcano convulsed again. Earthquakes reached magnitudes up to 4.7. Monitoring equipment captured lava spilling from multiple vents simultaneously. New volcanic mounds towered 300 feet above the surrounding seafloor. The 2011 lava flows covered an area 3 times larger than the 1998 eruption. Then came 2015. On April 23rd, scientists monitoring Axial's inflation recognized the volcano had reached its critical threshold. They issued a public forecast. Axial would erupt before the year ended. The prediction proved accurate within 24 hours. On April 24th, seismographs recorded a magnitude 5.2 earthquake. Then the instruments went silent as lava severed underwater data cables. The volcanic throat had reopened. Each eruption followed a clear pattern. 13 to 15 years of gradual inflation. Predictable pressure buildup. Reliable threshold. Scientists built their models around this consistency. The pattern held for nearly a century. Now that pattern lies in ruins. The cycle that once stretched over a decade has compressed into mere months. The answer to Axial's terrifying acceleration lies deep beneath the seamount's foundations. Scientists examining the volcano's internal structure have discovered a hidden network that changes everything about how they understand the threat. Beneath Axial sprawls an extensive system of subterranean dikes and sills. These are magma-filled cracks that extend for miles through the oceanic crust in every direction. The intrusions do not simply feed Axial's chamber. They connect the seamount to the entire Juan de Fuca Ridge system. When the volcano erupts, it is not just releasing pressure from its own reservoir. It is tapping into a vascular network of molten rock that ties Axial to every major volcano in the Pacific Northwest. The implications are staggering. Imagine an earthquake striking near one of those magmatic veins. The violent shaking dislodges mineral blockages that accumulated over decades. Pathways that were sealed suddenly clear. Pent-up magma that had nowhere to go finds new routes upward. The pressure injection arrives at Axial from sources far beyond the seamount's own footprint. This mechanism explains what scientists observed in 2025. The Kamchatka earthquake did not just send seismic waves across the Pacific. It hammered Axial's subsurface plumbing from 4,000 miles away. The Tonga rupture delivered another blow from the south. The Blanco fracture zone swarm struck from just 60 miles distant. Each event uncorked bottlenecks throughout the underground network. Each one mobilized magma that had been trapped in distant chambers. Axial is no longer inflating through gradual accumulation in its own reservoir. The volcano is being force-fed by seismic stress transferred across the entire Pacific Basin. 3 massive earthquakes functioning like pressure injections delivered directly into the volcanic system. The seamount scientists thought operated independently is actually a node in a continental-scale network of molten rock. The magma chambers beneath the Cascade Range share connections with this same system. Mount Rainier, Mount Hood, Mount St. Helens, all drawing from the underground architecture that Axial now reveals. The volcano is not acting alone. It never was. The consequences of Axial's accelerated eruption extend far beyond a patch of seafloor. 600 miles of geological catastrophe wait to be triggered. The Cascadia subduction zone stretches from Northern California to British Columbia. This massive fault marks where the Juan de Fuca plate dives beneath the North American continent. The subduction interface is capable of unleashing magnitude 9 megaquakes that dwarf anything in modern American experience. The last major rupture occurred on January 26, 1700. By historical standards, the fault is overdue for another catastrophic release. Dr. William Wilcock, a University of Washington geophysicist, outlines a chilling scenario. Axial's eruption could trigger earthquakes up and down the subduction zone, not just by transmitting seismic waves through the crust. The eruption could fundamentally alter stress patterns and fluid pressures along the entire fault system. The domino effect begins beneath the seamount. Axial's lateral dikes and sills rupture during eruption. Shock waves race through the Juan de Fuca plate's brittle crust. Those fractures weaken an already unstable fault system that has been locked and loading for over 3 centuries. The subduction interface could uncouple catastrophically. A magnitude 9.3 earthquake would hammer the Pacific coast from California to Canada simultaneously. But the seismic devastation represents only half the threat. The Cascade volcanoes share magmatic connections with Axial through the same underground network. Mount Baker, Mount Rainier, Mount Hood, Mount Shasta all draw power from interconnected magma systems. An eruption at Axial could mobilize molten rock throughout the network. Multiple volcanoes could erupt in a cataclysmic chain reaction. This nightmare scenario is not fantasy. Core samples drilled from Pacific seafloor sediments contain the evidence. Layers of volcanic ash alternate with turbidites, the signature of massive underwater landslides triggered by titanic earthquakes. Those layers appear in rhythmic pulses throughout the past 10,000 years. The catastrophe unfolding around Axial Seamount may be an ancient pattern written into the Earth itself, a pattern now accelerating beyond all predictions. Axial Seamount remains the most instrumented underwater volcano in history. Dozens of sensors carpet the summit caldera, transmitting continuous data through cables that stretch hundreds of miles to shore. Pressure monitors track inflation down to centimeters. Seismographs record every tremor. Temperature probes measure hydrothermal output. Scientists monitor these feeds around the clock, watching for signs of imminent eruption. The 95% inflation threshold looms over every data point. That same level preceded every major eruption in the modern record. 1998, 2011, 2015. Each time Axial reached this pressure, massive lava flows followed within days or weeks. The historical consistency offered comfort. Scientists knew what to expect and when to expect it. That comfort has vanished completely. The timeline compression changes everything about prediction. Models built on 13 to 15-year cycles cannot account for external forcing from distant earthquakes. Remote seismic triggering remains poorly understood. The mechanisms that accelerated Axial's inflation were not part of any forecasting framework. Scientists who successfully predicted the 2015 eruption now admit their methods no longer apply. When will Axial erupt? Days? Weeks? Months? The honest answer is uncertainty. The volcano has entered territory where historical patterns offer no guidance. An eruption would unleash massive lava flows across the seafloor. The summit caldera could partially collapse. Magnitude 5 earthquakes would ripple through the region. Underwater communication cables crossing the Pacific could be severed. Shipping routes might require emergency rerouting. These consequences remain manageable compared to the larger threat. Pacific Northwest emergency managers are reviewing response protocols. Coastal communities are updating evacuation plans for tsunami scenarios. State officials coordinate with federal agencies about potential Cascadia events, but preparing for what exactly remains unclear. The range of possible outcomes spans from isolated seafloor eruption to continental-scale catastrophe. Every sensor reading gets analyzed. Every micro-earthquake cataloged. The volcano that scientists thought they understood now behaves in ways that defy their models. The watching continues. The waiting grows more tense by the hour. The ancient pattern is shattering before our eyes. What should have taken decades is unfolding in months. A volcanic system that scientists studied for generations has suddenly broken free from every predictive model ever built. The rules that governed Axial Seamount for nearly a century no longer apply. 3 massive earthquakes from across the Pacific Basin delivered hammer blows to a volcano already primed to erupt. The Kamchatka rupture, the Tonga Trench collapse, the Blanco fracture zone swarm. Each event accelerated the timeline. Each one pushed Axial closer to its breaking point. The 95% inflation threshold that preceded every modern eruption has been reached 10 months ahead of schedule. The magma is not building gradually anymore. It is surging toward the surface with unprecedented speed. But the true terror lies not in what Axial will do alone. The seamount is connected to a continental-scale network of molten rock that feeds every major volcano in the Cascade Range. Mount Rainier, Mount Hood, Mount St. Helens, Mount Shasta, all share the same underground architecture. When Axial finally breaks, the energy release could propagate through interconnected magma chambers like electrical current through a circuit. The Cascadia subduction zone waits in the shadows. 600 miles of locked fault line capable of unleashing magnitude 9 megaquakes. The last catastrophic rupture occurred over 3 centuries ago. Core samples from the seafloor reveal this disaster has repeated in rhythmic pulses throughout the past 10,000 years. Volcanic ash layers alternate with the signatures of massive underwater landslides triggered by titanic earthquakes. The evidence suggests that what we are witnessing is not an anomaly. It is an ancient cycle written into the Earth itself. The most monitored underwater volcano in history is screaming a warning from the abyss. Scientists who successfully predicted Axial's last eruption now admit they do not understand the new timeline. The models they trusted have failed. The patterns they relied upon have collapsed. Every sensor on the seamount confirms the same alarming trend. Pressure building, earthquakes multiplying, inflation climbing toward critical levels. 300 miles off the Oregon coast, in complete darkness beneath 1 mile of crushing Pacific water, a geological monster stirs. The volcano best positioned to light the fuse sits alone on the abyssal plain, invisible to the surface world, but connected to everything that threatens to reshape the Pacific Northwest forever. The questions that remain have no comfortable answers. Will Axial's eruption stay buried beneath the waves as previous events did? Or will this accelerated timeline trigger the cascade that scientists have feared for decades? Is the Pacific Northwest witnessing an isolated volcanic event? Or the opening sequence of a geological catastrophe that could affect millions? The climate crisis taught humanity that Earth's systems are more interconnected than anyone imagined. Now the geological crisis is delivering the same brutal lesson. 1 mile beneath the Pacific Ocean, the clock is ticking faster than any model predicted. The countdown has begun, and no one knows exactly when it reaches zero.